my presentation, it's not, for beginner devs. So it's more about how to, if you're building or architecting, or if you're in some sort of leadership position, or in a decision-making position, to create or maintain or expand a MERN application. Here are some humble suggestions from me. So I'll go to the next slide. Yeah. So I work at Vaco. I do technical solution delivery, which means I understand. I speak with the client to understand what they're looking for. I work with their lead engineers to understand, where they're at, where their problems are. Spend a week or so reading their code and watching how their developers work, and pitch them, what we could do, what we could bring to the table. I'm a JavaScript nerd. I haven't done anything but JavaScript out of school. I just love the language. I love the community. And yeah, I do open source as well. We go under Blast Engine. It's a couple of colleagues from university. Yeah, you can find me in this link, I suppose. So yeah, that's it for me. So again, this is for somebody, for a decision maker, trying to build a strong product, right? So in my estimation, there's two basic, it's a duality, what defines whether a product is going well or not. One is quality, which is like, does it work, right? Are users happy with it? Is it, performant? Do people feel like it, it feels modern, it feels like it works well, no latency, there's no weird bugs, when we're deploying, there's, people don't come complaining, right? And that's what keeps product management happy. And this is usually what ends up being, what ends up having the more attention out of the two. And I think, being all developers, we've all had experiences of being put on a project where in the back of your mind, you're thinking, I mean, they're paying me, but this is a disaster. You're wasting money. And you feel like, your developer hours are, you're charging, money to do what they ask, but it just takes so long, and there's so many problems with, their product and the way that people, and the process around the product. So when I talk about product, I don't mean just the technology, although this talk is purely technical. I mean, how do we leverage, like when we are thinking about engineering decisions and architectural decisions, we have to keep in mind that our goal isn't just for it to work well, but it's for it to work to continue to grow in a healthy manner, right? So that's why I said quality is like the current value. Oops, how do I go back? And development cost and velocity is the investment value, right? So here's where we are. It works, but it's a mess, and you don't want to touch it. You just want to code freeze. Nobody wants to go near it. It's like, it works, don't touch it. The investment value is pretty much zero, right? If you want to add on some cool stuff to that, my honest recommendation would be, have a two-app approach, start migrating into a new thing, because you do get to a point sometimes where it's more expensive to build certain features than to try to refactor certain parts. So I would break that down into velocity, which means how fast can we produce stuff, how, like, the process and the technology, like the code as it's built, and the DevOps, right? Do they allow us to have quick iterations and get stuff to prod and be confident with it? Or do we have to, spend a bunch of time working on it and then have quality assurance, do manual regressions? It's slow. Cost is like, how many man hours does it take for somebody to do something? I've been in projects where, especially the big project, with big corporations that have the money and don't really have that much experience building modern apps. They will, pay exorbitant amounts of money for relatively small features, because there's so much tech debt involved, and there's so much, that a developer has to understand because everything's coupled together and it's kind of a stringified thing. And we've all been there, right? So it's expensive, right? You need to hire experienced developers to be able to understand how to make that work, right? And then scalability. Like, if you care about growing your team and growing the speed at which you deliver value to the product, at which your investment into the product actually pays off and the value of the product, then you have to think about, am I able to bring in new people, or is the onboarding going to take them 4 months and then they're going to quit because they're frustrated? So this is something that product management doesn't really see too much. So it's usually the second one, the investment value, that is usually the pain point for the engineering people, and I'm sure you would all agree to that. So the challenge of the engineering lead is to, I would say, nourish these two conflicting priorities, and keep them both healthy. Because I find that when one of these starts going down, it hits a threshold where it's like quicksand. You hit a point where, man, now fixing this is really, really expensive. So you're gonna have to live with it, or do like a major refactor, or start adding microservices to replace what you already have and stuff like that. So you want to avoid that. So what do I mean by, let's give some examples of, like, what these problems look like in real life. So a health check. So performance, does the app feel like your university portal? Does it feel like you press a button and it takes forever and you don't know if it even recognizes that you pressed it, and then it takes you to a different page and it takes forever to load and it's just awful? Usually, modern React apps don't have this problem. Robustness. Do you trust your automated test? So people, it's been a while since I've been on a team that doesn't do automated tests. Everybody seems to respect them, but I find that a lot of the times they're actually a detriment to the team. Maintaining automated tests is no joke if they're not written in a conscientious manner that is planned to be effective and cheap enough. Like, so you find that they have automated tests, but then they also have manual regression teams in India that need to approve everything going out, and they find bugs because the automated tests aren't doing their job, right? You have 90% coverage, but you still have bugs. Does new code tend to cause unexpected bugs somewhere else? That's a clear sign of, like, the decoupling is non-existent, right? You don't have separations of concerns. And if you get phone calls at 3 a.m., it means that, like, you're part of the infrastructure team, and I don't know how to help you there. So cost and velocity. This is the interesting one. Do your devs know how? Do your devs know how to go about doing their tasks from the get-go, including the fresh hires? So if I hire somebody, he's a weekend, so he's installed the local setup, he's good, and I ask him, hey, can you do this feature? Does he know how to do it, or is he like, oh man, how am I gonna do that? And he's reading code and getting frustrated and asking for help, right? Does it take longer to write tests than actual code? So that's going back to the automated tests, right? Are the tests a hindrance? Because I've been in projects where, like, the tests weren't doing anything, but anytime you changed something, a bunch of files would complain that their mock now didn't fit the interface or something, and it would just take forever. Do understanding yes, does understanding the functionality that you're interested in require you to read too much code? Like, you need to go down tunnels to understand what's going on? Is it hard to navigate and understand? Do peer reviews produce, this is actually one that I don't see a lot, do peer reviews produce valuable feedback? I find that honestly, every company that I've worked on, every single one, including the best, I worked at Wrangle.io, who's supposed to be the cream of the crop when it comes to process and stuff like that. And peer reviews do not produce valuable feedback, in my opinion, a lot of the time. Usually it's, syntax, oh, you should use a reduce instead of a while loop. And it's like, I agree, but like this is not helping the value of the product. This is not preventing the product from, like, what is the actual architectural difference? And the truth is, if the code is not structured enough, it's hard to read and understand and come up with a better way. You pretty much have to do the task yourself again. And then the last question here is, do you trust your devs? Do you trust your devs to commit code that will not be a detriment to your goals? The goals being these: to increase velocity, lower cost, scalability. Like, if you take a 2-week vacation, do you trust that the code will be okay when you come back, or will it be worse? So I'll do a little disclaimer here, because I'm going to propose some suggestions that I've found very helpful in my consulting engagements to kind of deal with these problems. But I'll say that I've been the ideas that I'm going to present here are very specific to, like, the examples that I'll provide and the specific language that I will use will be all kind of MERN stack, right? So if you come from a different language, it's the principles will still apply, but you'll have to use your imagination a little bit more. And I also won't be talking about how to, and these really interesting projects have been where they know that their application is in trouble, that they're spending way too much money to build features and they're falling behind. And they ask us, what can you do to fix it? How can you improve it? Those are really interesting and really tough assignments, but we don't have time. It's out of scope. So we're going to talk about just general principles, and I'll show you. I'll try to show you little code bites from a little project that just put together really quickly. So I warn you, it's going to be full of bugs. Don't get mad at me. It's more about, like, what is it trying to do than what it's doing. Okay, so general principles that I live by. Immutability. This is not new to anybody. Oops. Jesus Christ. Immutability. And this is simple. Just never mutate JavaScript objects. Like, if you can just follow that rule, you can never go wrong. So basically, because you don't want to keep track of them. You don't want to keep track of what mutations occurred. You don't want your object to get changed by somebody else. And these can lead to really weird bugs that I've seen many times, where, like, you don't know where these properties came from, or where this got changed, and you see that, like, down the line, but in some other component, somebody added a property that is messing you up. A mutation is a side effect, and we're going to talk more about that. But we do not like side effects, right? We don't want to affect the environment as much as possible in our code. So immutability, just kind of take it on faith. It's always a good idea. Now, purity is related to immutability. This means no side effects. Like, the functionality that you build should only return a value and accept no external influence other than its declared parameters, right? So you're not importing some config and then using something from there, right? You're not, modifying, mutating. If you mutate the input, for example, you're no longer pure, right? So I guess we're all familiar with the concept of purity, but the reason why is that this is very testable. It's very robust, because you feed it something, same input, same output, right? It's also very easy to read, because the reason stuff is hard to read sometimes is because you don't know where the affecting factor is coming from. But in a pure scenario, you know exactly where it's coming from, and you can test it out. You can just grab a pure function, especially if it's accessible, which I will get to, and then test it out with a couple of things and see if it's that's the problem or not. And also, it's highly reusable, which is great. So this is important. Most people, when we're talking about purity, they think pure functions. The problem with just pure functions, like Redux does it, is that they're not organized by functionality, right? They're all just kind of standalone functions, and they get mixed and matched, and you get lost, and they start calling each other, and then you have to follow the chain of dispatches that happen, right? Purity is not just functions. You can have what's called a pure model. A pure model is an object, like a class, you can think of it, that accepts, some constructor parameters and doesn't mess with them. Imagine like a class that you just give a config object to, and then you ask it questions, right, based on that. So you can give it a bunch of data. You can be like, you're the model, you're the user model. Here's the user data, but you're immutable. So you just answer questions about the user model. Or for example, tell me how to update, this particular property, right? And maybe the user model will tell you, okay, here's a query that will do that if you give it to that service, right? That's still immutable. And that follows that has all its purity. Yeah. And then the last point is the problem also that people find with purity is that obviously you need a lot of parameters. And I find that a lot in Redux, where people are like, oh, how do I get access to the state? Like, I just want the state. Where is it, right? Well, we want to facilitate the use of a pure construct by provisioning it. This means having the class, split its arguments into two parts, right? And then you can fill in all the ones that like are standard for every one of that kind. And then the last little argument is what gets called by the actual component or whatever. So it doesn't have to be a pain in the ass to, sorry, I shouldn't say that, but it doesn't have to be a pain to use pure constructs. Then effects. Effects is what we've been trying to avoid this whole time, right? But effects are kind of the whole point of the application, because like at the end of the day, the application is supposed to, turn on the light in your house or show you some UI or play you some music, right? That's an effect. So we're gonna have always some effects, right? But what we want to do is capture them within services, wrap them in our own API, because we can mock that after. We can mock that interface and use that in our tests. Yeah, effects are not easy to test. Like you can make a mock for it, but how do you know that the mock is that close to the actual, effect? Like you can write some tests for this, some automated tests that like actually ping a remote service and see what kind of things you get back. But these things are notoriously unreliable. They're not part of your code. You can't trust it. So what we want to do is not rely on, but it's not just outside stuff, databases, state, anything that is affecting the environment of the application. Calling a pure construct doesn't change anything. It just gives you a result. But anything that actually makes a change to where you are in the application, you need to push those services far out in terms of the dependency, right? So that you mostly interact with things that are pure logic, testable, and you do all the complex work within your business logic, within your client GUI logic, all this stuff that's kind of pure. And then at the end of the day, it's like, okay, call the service, do this thing, right? If you keep them accessible for debugging, which is something that I'm a huge fan of, you should keep a lot of stuff accessible for debugging. In the window should have all your services, because you can test stuff out and you can debug a lot easier. I've seen so many projects where people they want to test this particular API request. So they have to figure out what action do they have to dispatch on Redux to get it to call that API. And then it's like, you have to get to a particular state. It's like, no, the service is an independent thing. The service doesn't know anything about the application. You should be able to just call the service directly. Okay. However, so we're mocking the services, but don't mock yourself. And this is something that I've also seen as a pitfall. We mock services because we want reliability. We want simple tests. We don't want to, have to establish a live service connection to run tests. We want the exact same behavior. It could be expensive, whatever. However, we do not mock the dependencies that are our own code, because many reasons. But like the first one here is like writing the mock is like writing the same thing twice, right? Because that's what it's doing. Hard-coded data is very common, and I've seen it a lot from junior devs, where like they'll make a little, for example, they make a Redux module, right, with some reducers, some actions, and they'll just test it with like JSON inputs and outputs, right? The problem is that if those JSON inputs and outputs were to change, yeah, you still pass the test, but it's wrong. You're still gonna fail, right? Because your yeah, here, if you're only testing that unit, you should be testing actually if you work with the system, because that's the goal. The requirement of that unit isn't to do that function, it's to do the correct function to serve the system, right? So what we should do is, for example, I'm saying here, but did I talk about kinds yet? Okay, sorry, I got ahead of myself here. But if you're testing a kind, and a kind, imagine as anything, right? A class, a function, you're testing this thing that takes as an input something else of like a class, an object of a certain class, and that object could have some state, and you want to test it with different versions of that state. You want to test it if it's ready, if it's not ready, whatever. You don't feed raw JSON. You produce the mock versions using the APIs of K2, right? So you tell K2 like, okay, initialize, add user, whatever, get it to the state that you want, and then hand it to K1. Why? Because now if you change the behavior of K2, immediately the K1 test will fail, but that's a legitimate fail. That's a fail that would have happened in production. And that's something that is way easier to maintain, because if you change the behavior of K2, but you had hard coded all the presumably K2 outputs everywhere else, like now you have a nightmare on your hands. So don't mock anything that is your own code. Build the mock state that you want from scratch. Okay, centralized state. This is an obvious one now, since Redux took over the world. But basically the idea is that you're not going to be able to have one centralized state most of the time, because, and again, most applications communicate with external services that have their own state, right? So there's some state that is inaccessible to you, and you don't want to be synchronizing state. That's too much complication, is too error prone. But here's the rule: if you must have multiple sources of truth, make sure they're different and independent, right? So your Redux, if you have, for example, a subscription to a web worker that's feeding you, computed results once in a while, right? So the state is in the web worker. You don't have access to it. So you have a service around the web worker emitter, and then you have a service around the state. They shouldn't really talk to each other. It should be like, if I, as a component, I'm interested in both of them, I will ask each one separately, because otherwise the states become, you have a synchronization problem that you don't want to deal with. Also, another thing, Redux does this very poorly. Redux does not modularize their state management, right? So Redux just tells you like, oh yeah, you can have sub-reducers, I guess, that like, yeah, you can define your reducers, but it's not very good. Like, people end up, it's very easy to just kind of break that rule and call something that you shouldn't. Object-oriented programming has fallen out of style because managing state across the application, having multiple little bits of state, is a terrible idea, because it gets totally lost in the client and in the backend. But you can have an object-oriented style API that manages your state using pure models. So I'm going to demonstrate this in a second here. Actually, let me show you some stuff. So I guess you guys know purity, you know immutability. Okay, let's start with centralized state, right? So if I have like, So I'm not using Redux here, but it's pretty much Redux, right? So I have a really simple global UI. You can imagine this as a state module, right? So all it does is like, I'm not really running it, am I? Let's run it. Okay, so all it does is declare the kind of things that you would expect from a Redux consumer, right? And actually, this little library supports Redux, so you can actually wrap your Redux store in this, and then you have both APIs. You can use it as regular dispatch, or you can use this this syntax. So basically, what I have here is a query, which basically says, get me this value, right, from the state, and not just from any state, from the module state, because we want to modularize the state. And then transitions are like, it's like an action plus a reducer. All it does is like it takes a state and it returns a new state, right? So I define two transitions, one to open the modal, one to close the modal, and a query on whether the modal is open. So all of these are pure functions. There's nothing weird here. I'll show you right now when it boots up. So yeah, it looks terrible, but please bear with me. So if I have, this is what I mean by accessibility. You should be able to play with, at the end of the day, the services being the only ones that support effects will be able to control your entire application, because your application is always listening to those services. So if I go to global UI here, so the first thing that we did here, so this object right there that got passed into module is called the definition. So what we have is, some queries and exactly the stuff we gave it, right? So if we do a queries, let's see what we got, open modal. This is what I mean by this, by pure model. So this is a pure model. It's saying I have some queries and I have some transitions, but they're all pure functions, right? So it takes a state and it takes a module, right? Okay, let me write another one that doesn't use a module. That one depends on it being provisioned to have a module. So let's say state, and from state, I'm gonna grab X. And I'm also gonna add a transition. I'm gonna call set get X. What's my time, Adam?
Yeah.
8 minutes? Okay. Let me just do this really quick.
Sorry, there's no rush. I didn't realize I muted myself. Take your time, mate. No rush.
Oh, okay, I'm not gonna take too much more time. Okay, so we have set X as a transition, which means, see if we can read this, right? So it's saying I'm declaring a transition, and you don't need to worry about what that means, but it doesn't do much. All it does is define this function, which is you give me the state, and I will give you a new state, just like a reducer, right? With a new value for X. And X, let's say args. Okay, let's call it val. Okay. So I'm going to save this. Hopefully it doesn't crash. All right. So in my definition queries, get X. Right. So remember that this, I'll do this fast, don't worry. Okay, so in the queries, get X, all it's doing is getting the value X from the state. And it requires a state. Right? So I can give it any state. Let's say my state is Y, E, and X, R. Right, and what it returns is a query. So it's pure. It's just what it does is generates a query. So if I give this to one second. This takes me another 2 minutes, then I will stop. Yeah, yes. Yes. No. Oh. Sorry, so I definitely screwed up that demo, but basically, you get the idea. You're defining queries in this manner, and then when you call open modal, it will add that in there. Blah blah. So these are pure. So basically, what a transition does is it returns you a new state. What a query does is it returns to you a query. So when I call GT module, what it does is give me a still pure model. So let's see. So it'll be this. This is this model thing. This is the return of this function, right? So this guy will have provided the other queries and transitions to it, whatever. And then imagine that you have the same for okay. A module has dependencies. So do most services, right? So Firework, which is a service that I'll talk about in a second, requires config. And this makes it so that I can use it in different circumstances, in different places, right? I'm losing my. I feel bad about the shitty error there, so I'm gonna just backtrack here and move on with the slides. Not lose my mojo. Okay, so we're talking about purity. I don't know if you fully believe me yet that purity is a good idea because of that bad demo. But the idea is it is easier to test a pure function, obviously. And then if you provision, for example, say module A for the state, my example was global UI, right? Like which modals should be open. Say that one depends on authentication or something. You declare it in the dependencies of that module. And it's not so hard to do. And then when you're fully provisioning that module, and that means like giving it a state that it can actually save its stuff in, right? So it's like you're allowing it to actually have effects now, affect the application. At that point, it actually becomes, usable in the app. But before that, you can do all sorts of tests on it. Capturing the mock yourself. So the don't mock yourself one is interesting, but I'll come back to this in a second. Centralized state, multiple sources of truth. Yeah, it's unavoidable. Like, yeah, I'll go back to it again because Firework is kind of one of the important things there. Okay, this is important. So we've talked about what is it? And I hope you believe me to some degree. I mean, you probably heard these terms before, that these are usually good ideas to have, right? And that, also separation of concerns, modularity, everybody loves these words, but then we find ourselves in projects where boundaries aren't respected. So I feel like this is the solution that has worked for me very well, which is every line of code should exist in an explicitly defined kind of thing. And a kind of thing could be like a function, a type of data structure, a file, a directory. It can be anything, a package, right? And every kind is given explicit rules, like written, like we have a wiki about what it can and can't do, right? So when solving so what can, for example, here's some examples. What can this thing depend on? What can we import and accept as arguments? Is it async or sync? How should this thing be tested? What kind of logic should it contain? What is it agnostic of? Like, what does it know, right? Where should it be placed? So let me show you some of like my kinds, right? So they're pretty. So for example, I'll have utils here, and my real utils, they're so far removed. Like if you really want to segregate something so that to enforce that people don't actually violate these boundaries, you can make them, different packages. These blue ones are actually not just packages; they're submodules, right? So these are all open source, and and the ones with the underscore are actually the ones that are relevant to this application, right? So I have a utils thing here, and these are all just utility functions that I find useful, like is it an array, whatever, sleep for a while. This is like the bottom, right? Anybody can import this, whatever. At the top, we have the components. The components are the things that trigger things to happen. It's the components or the services. Those are like the two ends of like where effects happen and events happen, right? And then the providers will provide the services. So you have components. For example, an action can't import a component. A component can import an action. A component can import a provider. A component can import a service. You might notice that, like, look at these actions, right? So this is what I was talking about before. It's not a pure function. This is full of side effects, right? But we can do this thing where we provision. So when I pass in services here, now I can give this create group function to any component, and all they have to do is pass the name. So this is the general pattern. That is the simplest way of doing dependency injection. So like I even do it for components, and it's fantastic. So for example, here I have my group component, but it's actually a function. You have to like enable this. You only get the group component after you give me services, components, and config. And components, I'm not even importing. The components all come from here. So I call them. And that gives you a ton of power because group doesn't touch anything from its outside world. You can literally put this group in a storybook, as I'll show you now, mock the services that are external, give it whatever components you want, and see, for example, you're developing a container, but your friend is developing like the actual items that you're going to show. Well, you can just replace that component. You can say, for example, in the component provider, which is what this is, right? I can say like the component creators, if it's, this particular component, don't use that one, use mine, right? Which is just like an empty square. And same with services. You can create a mock version of Firework, which I painstakingly created, so that you can actually connect to it and get your data, and your component doesn't know anything about it. Your component being tied up and having, actually this takes me to the next slide, declarative subscriptions. This is like Redux brought this in and just like change the world forever. Having to manage numerous event subscriptions is bad for you. It's bad for your health. Don't do it. Because you have to manage like what this subscription brings that alters what I want to subscribe to for the second subscription. So I have to kill it. I also have to kill it when I go away. Is somebody else subscribing to it? Like there's too much back and forth. And also they come, like you need a handler for each of them. And each handler, you need to see, okay, do I have the other values? It's complicated. But there's a really elegant solution that Redux brought in, where components just declare their data subscriptions via selectors, right? So we don't have to keep track of which subscriptions we have open, nothing. It's just, you only need one handler. It's just, they just all get passed into your props and your render figures out what it should be showing, right? This approach should be used for every event because it is the best way to handle React components. Like React components should be just only re-rendered when the props come in, and if you pass them the same reference, they will not re-render as long as you're using React pure component, or if it's a functional component, use memo in order to establish that. But for example, if you need to subscribe to web worker events, like as I said before, this is a different service. You would just grab it from services and connect to it. Say, I want this data from web workers, and let it come to your props, and let it, unmount whenever you're done. You don't have to worry about it. Yeah, we achieve this with a higher order component if you're in a class-based thing like I am, or with a hook sometimes. So this declarative subscriptions are great, basically. And I'm going to propose to you an idea that I've been convinced it's great for a while now. I've done a bunch of projects with it, but usually, it needs to be a greenfield project in order to get so ambitious. But you know how a component has a state, and if that state changes, like we're watching that state. Also, the component is subscribed to the Redux state, which if it changes, everybody gets notified, and if they care, they will re-render. We should take that one step further, because we can 100% imagine the system database as the state of the system as a whole, right? You have multiple components listening to the Redux state, and you have multiple clients listening to the database state. So the beauty of this is that most applications now, they have to manage their own WebSocket connections. They have to do HTTP calls themselves. But there is no declarative subscription to state of a remote database. So what I'm suggesting is your component declares the data it wants from the central state. And this is shared by all users. Obviously, there has to be rules about, and there are, about, what data you can access. And then the same state operations that we're used to would apply in the same way, right? You have reducers, you have selectors. But you're working on the central database itself as your state, and the updates come to you through WebSockets. And this frees up the problem 100% of having to sequentially make HTTP calls or maintain WebSocket connections. The other beautiful thing about it is you can have an isomorphic pure state model. So as I was saying before, in that demo that crashed and burned, I had a model of what that functionality did, which was open a modal, close a modal, but it didn't do anything until you gave it like an adapter, right? Until you gave it a store to actually do those operations on, right? So this is what I have. We use the same idea for the server, for the actual business logic. We have a thing called entities, and this is just part of the, I'm showing you guys a particular framework here, right? But I hope you get the general idea. So for example, so here, let's say I have a node. This is a tiny little model, right? It has these functions, whatever. They usually get pretty complicated. This is also a pure immutable model, which means you can instantiate it once and it will never change the data inside it. However, you can ask it to perform updates, right? So if I go to users, for example, I'm sure it will have, see set user, and it will return to you an update object, which you will then provide to the framework, which is called Firework, and it will send up that thing, the actual update to be performed. Now, this kind of thing has been tried before, but the problem is in Redux, you always have access to the whole state, right? So any query can derive its value by computing. It can go anywhere in the state and grab whatever it wants and compute it, right? But instead here, we'll always have an incomplete representation of the remote state because we can't have the entire database in the client. So basically, what you need to do is make requests for what you want, cache whatever you can for efficiency, and then we have to be smart about how we're caching it. I don't know if you guys worked with GraphQL and Apollo. They were doing this for a while, but I don't know. It wasn't working great for me. So this is the solution I proposed. This is what Firework does. So the concept of an atomic model is kind of like the building block. Like you can't break an atom, right? It's the building block with which you define the remote central state. And remember that so hold on. So the definition of an atomic model, and the model is the definition, right? The pure definition that doesn't, have a connection to anything. It's just a wrapper for some data. An atomic model is such that we're okay with always receiving the whole data. You can't request partials, right? And also that user will have access to all the data or none of that data. So you need to separate your data into these atomic little parts that will fulfill that criteria. The component declaratively makes a query for something complex, right? For example, they want a list of groups with all their likes and all the users associated with them. Like there's a lot of stuff there, right? The component declares a composite query, a query that's like, I want some serious data. I'll show you an example. So if I'm in here and I have, okay, fetch groups light is actually a pretty complicated, like the groups are pretty complex. They have like, who is the owner? What are the last messages in it? How many likes? All that stuff. But all these are atomic, right? So when you give this to the Firework Connect function, what it does is break it down. And the way it's broken down is actually explained in the definition, in the pure definition of that model, of how to get it. So look, I have a fetcher here. Oh, actually, this one isn't that bad. I think the posts one is a little bit more interesting. Yeah. So I'm saying fetch me all the posts for the group, right? So first we need the group. So we make a query for that group information. Then we need the group's owner, because the group will just have an ID. And we want to do that as much as possible so we can reuse, right? Because if somebody else requests something that also wants that same user, we don't have to fetch it. It's already cached, right? So it does that, takes step by step to figure out which post we should get, which other users are authors. And then it creates this model that can work with all of that, right? So that's all abstracted to you, and it looks to you like a structured model that has all this stuff going on, right? And this is stuff that you can test very easily. But basically, as you can surmise, here, when I'm looking for groups and owners, if it's the same owners and groups, right? Like these are atomics, right? So if I already have these ones, I'm not going to get them. And then basically I'm banking on the power of the client nowadays to be able to put it together. So when I request here, get me this complex composite model, my client is actually going to request for each individual atomic thing and then check, are we done? Do we have everything we need? Do we have everything we need? And once it is ready, then it will submit the event and pass it as props down to my component. But it's very similar to Redux, right? Like the syntax looks super similar. It's just there's a cache, and anything that's not in the cache we're fetching from Firebase, right? Look how this can be. And again, I'm not trying to sell you on this framework, but what I'm trying to sell you on is the idea of making your the logical parts of your app separate and testable. Like make them pure models, because look at this. I have like users and I have a state builder. So what this is saying is get me user basic list. The name is create users, right? So it's going to take a fireworks service, but this is a mock. It can be a mock or it can be the real thing. We don't know. So we're saying get me the user basic ref, and then for all of them, add a user with some random name to it. Perform it, whatever, and give back to users. And then in groups, we're basically here, state builders. In groups, we have create group, which is okay, give me a user basic and I will use him to create a group and update the state there. So basically, you're like building a state, right? So in my test for create groups, all I have to do is instantiate a mock version of the fireworks service, which instead of making requests to the server, it will actually keep everything in local cache. And then I call the state builder using this thing and telling him how many I want. And then I should have ended up with 5 groups, right? So I didn't use any mock data. And if my user if my user API was broken, this test would have failed too, and it would have told me that it was the user. But we never left this actual package. This package does nothing. All it does is define these functions, right? And what's great about that is you can even, so since all of my things, all of my kinds are all pure, right? They all take provisions, but they don't grab anything from outside. What I can do, where is it? Group component, right? So this component, for example, I can mount it on Storybook. So when I mount this on Storybook, what happens is I have a util here for that. It's a little bit complicated, but this is the important part. It creates the service provider. So it's saying, I want to init, I want to have firework. I want it to be mock. So it's going to be in memory. And then I want to, have components, whatever, that's it. So, okay. Okay, so it's not very pretty. And the button actually is funny. The button doesn't work because I didn't provision it with a Redux store, right? With that, that little service that used the Redux store that I couldn't get to work. I didn't even provision it. So the button does nothing. However, the component is still hooked up. It's subscribed to this firework thing, right? And I have an ability here to mess with it all I want. So for example, I'm going to use one of those things that we define in entities, right? Which is like this, right? Create users and groups. This thing will create a certain number of users, and then each user will create a group, right? And all they're doing is like they're telling Firework to do it, but Firework is just local cache. So oh, right. Okay, so I'm gonna call for 10. So you can see that I'm passing the service Firework that was injected into my story. And I don't have a freaking entity, son of a bitch. I don't have entities, really. Okay, well, I can do it in the real app. So now the beauty of this that I'm trying to get across is the fact that if you have a developer that wants to, for example, improve, they want to add functionality to, let's say, collect performance data on the app, right? They would know that it has to be a service, right? And it will have to be provided to the component. If it's business logic, right? If it's like, oh, I need to be able to like a comment, then they would know that it would be one of these and how to test it. And there's really no way to screw this up too much because you don't really have to anything here, right? All you have is this like pure definitions of like of static stuff, right? Especially since it's in a different component. By the way, this can be imported into a backend, and you can use the same models to update a Mongo or whatever. Anyway, I'll just show you this, and I guess we'll be done. So I have see if this one will let me. No. And why stuff worked before and now not anymore? So annoying. Getting here? Let's delete everything. Yeah, I don't know. Obviously, the demo that I worked so hard on didn't work out, but I hope that what I was talking about made some sense. I would be very happy to discuss. If you have any questions about it, because I know this demo was a complete failure, but I've built pretty robust apps using approaches like this.
What's the difference between the framework you were using versus actual Redux?
Oh, you mean Firework or GT Store? I'll show you what I mean. So do you mean this one where I'm querying if the modal is open in the store?
Both.
Okay. So the main difference is that Firework, you're asking for state that is remote. This is like the state that every user shares, right? So we keep a cache here. And when you ask for something, we're going to break it down into its atomic pieces, right? Into like, okay, what are all the little things I need to get to put this thing together? Reason for that is so we can share them, right? So we don't always have to be fetching the same data. But if we don't have a piece of it, then we actually go and grab it from the database. So this is my I/O. and it looks the same as Redux. That's no coincidence.